Alright, so we've been working on sketching functions, so I'm going to sketch this. You'll notice a of x, it's cubic, so at most the graph will touch the x-axis 3 times. And I know how to factor this, but you don't know how to yet, so we're not going to. We're going to let the first and second derivative do the work for us, since this would be, very time consuming to factor. So I took the first derivative, and I ended up with 3x squared minus 12x plus 9. I factored 3 out of each of the terms, so I ended up with 3 times quantity x squared minus 4x plus 3, and then I went ahead and factored out this trinomial. So now I have 3 times quantity x minus 3 times quantity x minus 1. That tells me that my possible maximums and minimums exist at x equals 3 and x equals 1. Alright, so I'm going to go ahead and pop these back into a of x. So I can find the y coordinates. So when I do that, I put 3 in a of x everywhere I see x. So when I do that, for 3, I end up with a of x equaling 1, or y equals 1. And when x equals 1, a of x equals 5. So let's go ahead and use the second derivative to figure out which one is the max and which one is the min. So I'm going to say a double prime of x equals 6x minus 12. So to find which one's the max or the min, I go ahead and plug in the x coordinate everywhere I see x, and then I'm looking to see whether or not the sign is positive or negative. Okay, so I end up with 18 minus 12. It is positive, which means that this is a minimum. And this is definitely a maximum, but we'll just double check and make sure. So x double prime of 1 equals 6 times 1 minus 12. It's negative. So this one has a negative sign, this one has a positive. So since this is negative, it means that this is a maximum. Okay. The last thing we want to do is we want to find the point of inflection. So I'm going to go ahead and set my second derivative equal to 0, because this is what defines a point of inflection, and then I'm going to solve for x. So add 12 to both sides, and I end up with 12 equals 6x, so x has to be 2. So my point of inflection happens when x is 2, and that would mean I'm going to pop 2 back into the original equation to find the y value of my point of inflection. So I end up with 8 minus 24, which is negative 16, plus 18, which is 2, plus 1 is 3. So my point of inflection is 2, 3. So that's where my curvature changes. So if I wanted to see if it was upward or downward, I'd go ahead and make a number line. My x-coordinate's 2, so I'm going to pick a number less than 2. I'm going to put it in the second derivative and see what I end up with. So if I choose negative 1, I end up with negative 6 minus 12, so I end up with a negative value. Jacqueline, I'm using one negative sign instead of multiples. Okay, if the curve changes, I would expect this to be positive over here, so let's try 3. So I'm going to go ahead and pop 3 in here. 6 times 3 is 18, which we already did, minus 12 is positive, so this is positive. So this goes from a frowny face to a smiley face, like you guys like to say, when x equals 2. So let's go ahead and do a rough sketch of this function using the max, the min, and the point of inflection. So here's my graph. Okay, so sorry, this is rough because you can hear my baby crying, so I'm going to try to get through this really quickly. I'm going to go over and plot my minimum at 3, 1, and my maximum at 1, 5. Okay, and my point of inflection happens at 2, 3. Okay, so basically what I know is going to happen is this is going to come up. Oops, not quite like that. I'll do this in a different color. This is going to come up somehow like this. It's going to go down, and it changes upward, and it goes like this. So that's what this graph looks like